Hello, students. Dr. Church. I want to take just a few minutes and talk about energy resources. Last section study in our look at energy. So, what are energy resources? Let's jump right in. Non-renewable energies. Well, these are energy resources that you're probably very familiar with. Fossil fuels, fuels derived from biological material fossilized millions of years ago. Oil, gas, natural gas, coal. These are all fossil fuels, okay? These are non-renewable energy sources because there's only what's called a finite supply. There's only so much. It takes hundreds of thousands or millions of years in some cases to create these high quality energy sources, and that's just too long for those resources to be renewable. Nuclear fuel is also a non-renewable energy resource because it's from radioactive material, and there's only so much of that available in the ground, and we actually get that out by mining. Some of the patterns of energy usage throughout the world, of course, oil, coal, and natural gas. That makes up the vast majority. 5% nuclear, somewhere between 14 and 19% would be renewable energy resources, and we'll get to those in just a minute. Who's using the most energy? Well, of course, it's going to be your producing countries: China, the United States, India, Japan, France, Indonesia. These are countries that have fairly significant populations and high industrial output. If you've ever been in a factory, like I've been in car plants all over the Northeast and South, and they are using equipment that really uses a lot of energy. And so it's the industrialized nations that are really using the energy. Well, what about energy uses? If we look at the trends over time from about 1850 to say 2020, we have petroleum, natural gas, coal. We see that around the 1920s, 1930s. You start to see the petroleum products uses go up because oil is used in not only in running your car, but it's used in plastics and other materials and cosmetics and all sorts of things utilize petroleum as a natural resource. Of course, natural gas and coal, you'll actually see wood usage in at some points that actually dip just a little bit, but that's not really a primary source of energy any longer. Well, what are some alternative energy sources to fossil fuels or non-renewables? What is clean energy and how does it work? Well, again, if we look at that chart, somewhere between 14 and 19% it would be renewable. So that's biomass fuels, bioheat, ethanol, biodiesel, hydropower, wind, solar, geothermal, and even the ocean, the tides rising and falling can be used to generate energy. Clean energy is energy that's renewable. It can be replenished on the time scale, which is within a normal human lifetime. Unlike fossil fuels, which take thousands or millions of years. Clean energy is not generating carbon dioxide, okay, which is the infamous greenhouse gas. It also, you've got what's called SOx, NOx, and carbon dioxide, which is sodium dioxide, nitrous oxides, which are byproducts of burning fossil fuels, and carbon dioxide. Those are your greenhouse gases and pollutants that make smog. So, what is clean energy? Just more than fossil fuels. And so it's also easier to get into rural or underdeveloped areas. What are some of the renewable energies? Well, solar power. It's obviously the sun. You start to see solar panels popping up on people's houses now. And you can, the photonic technology within solar panels now, it actually converts that energy straight from sunlight to electric current, and then that electric current can be converted and used in your house. Nuclear power. We have a nuclear power plant about 30 or 40 miles from Wake Forest. And we've already talked about nuclear power when we did our nuclear power section, so I'm not going to go over that again. But nuclear power, that's kind of a cleaner energy because it doesn't emit uh, carbon dioxide into the air. So, but yeah, it's still a non-renewable. And again, just as a reminder, you got the fission reaction and then fusion reactors. I was just reading about fusion reactors again the other day, that they're getting ready to crank up a large fusion reactor that they've been working on for about 20 or 30 years trying to build it. And so that's ready to come online soon. That would be exciting scientific development. Wind power. The wind actually just turns a gigantic fan blade. That's a big fan blade, like it would be 30 feet long. You know, each one of those are pretty large, and it turns a generator, which can then be converted into electrical power. When I was out in California to visit my son a couple of years ago, they've got all these wind farms, literally just hundreds and hundreds of these gigantic windmills, wind turbines that are just sitting out in these fields, and the wind blows very consistently there, so they generate quite a bit of power from that. Geothermal we don't think about very often, but we know that the earth is warm. I mean, it's heated. It's heated from the inside out, and we can actually go down and tap into some of that energy and turn a turbine and a generator, and that's geothermal. Again, we're not going to study the specifics of how that worked. That would be a whole unit in and of itself, but it's very interesting. But that is an excellent source of energy in certain areas of the world. Of course, hydropower, dams, the potential energy of the water falling can be converted to kinetic energy to turn a turbine and generate electrical power. And again, a great study there. If we in class we could do some experiments with that and show how that falling water can generate power. The damming of a river can cause other ecological issues behind it, though, in terms of flooding and habitat destruction and things. So you don't really get something for nothing there, but dams are cleaner sources of energy in a lot of cases. Biofuels, you'll actually see these at the service station now, and you'll see the E85, which is, these are fuels that are still, again, generate some CO2 emissions because they are hydrocarbon fuels, but they're cleaner burning. They're a bit cleaner burning, and they're not fossil fuels. They're renewable in the sense that we can grow plants, corn, for example, and then convert that into a fuel that you can put into your car. And you actually are doing that. When you buy gas and it says 10% ethanol, you're using a biofuel. And you see the E85s, which are a little bit cheaper because they're subsidized. It's a little bit cheaper at the gas station, but you got to have a flex fuel car to run those. So be careful about that and make sure you're putting the right fuel in your car. And then finally is hydrogen fuel cells. When I was in college 30 years ago, I studied about hydrogen fuel cells. You put hydrogen in, you put oxygen in. That is a chemical reaction that causes electricity to flow and heat to come out, and so the byproduct is heat and water. So there's really no pollutants. The exhaust of a hydrogen fuel cell is literally just water, and so that would be an excellent source. The problem is you have to liquefy the hydrogen and put it into the fuel cell, and then that takes energy itself to make it, and so that hasn't been really a viable technology even in the last 30 years since I've become an engineer. And so that's the end of our unit, as we've looked at some energy resources. You got your non-renewables, that's your fossil fuels, radioactive energy, nuclear energy, and then you've got your renewable resources. Probably the most common that you're going to see is going to be solar. That's going to be something that's going to grow in your lifetime, so it's very interesting to learn more about solar energy. And some of you may even have solar panels on your house right now. And of course, hydroelectric with dams. You've got wind power that's popular in some areas. So these are alternative energy sources that are technologies, that application of science that is being used right now to make our lives better. So I hope this has been interesting, a bit informative about energy resources, and I hope you've learned something.